One of the benefits of producing this podcast at the University of Chicago is that there are often events on campus that bring in not just one big brain, but many, in order to find answers to some of the most complex problems of our time. I recently had the pleasure of hosting one such event on artificial intelligence that we want to share with you today. The event, which was part of the Graham School's Leadership and Society Initiative Symposium, examined how AI could change everything and, more importantly, whether it should. We'll be back with regular episodes in August, including some exciting new video offerings. You can already find clips of the Big Brains podcast on our YouTube channel by searching Big Brains Podcast. Stay tuned for more details soon. The University of Chicago Leadership and Society Initiative guides accomplished executive leaders in transitioning from their long-standing careers into purposeful encore chapters of leadership for society. The initiative is currently accepting candidacies for its next cohort of fellows. Your next chapter matters for you and for society. Learn more about this unique fellowship experience at leadforsociety.uchicago.edu. Okay, why don't we go ahead and kick off? It's so nice to see you all and have you here. My name is Paul Rand, and I lead communications for the university, and I'm also the host of a podcast we do on campus called Big Brains, if you've ever heard of that. And if you have been enjoying some of the folks that you've been listening to, we regularly feature new episodes every other week where we really kind of highlight some of the best academic research, not only on this campus, but other campuses across the country and across the world. We have got an extraordinary panel with some of the really the brightest big brains on AI when it comes to our campus. And rather than having each of them go and just do a straight down the line set of introductions, I'm going to ask them just to kind of kick right off, starting with Bob Grossman, and tell us a little bit about your day job, but also how did you first start getting involved in AI, and what are you most particularly excited about right now?
Okay. So what's my day job? I'm on the faculty in computer science and medicine. I take the simple point of view that anyone can build an AI model, but if you don't have the data, that model's not going to help. So I spend a lot of my time on making sure that there's data available in biology, medicine, and healthcare so that we could build high quality machine learning and AI models. I spend a lot of time building something called a data commons, which is we do it with open source software to manage, analyze, share data for a particular research community. We have one in cancer, which is the largest collection of genomics data and associated imaging and clinical data in the world to support precision oncology. And we've built these in other areas like cardiovascular disease, infectious disease, veterans health, et cetera. So that's number one. Number two, the reason I do that is so I can build small to mid-scale models over this. That's number two. Number three, we teach other people to do this because the more data out there that's controlled by the organizations that produce the data, like academic medical centers, the better it is to build these models and for the organizations to control how they're used. The second part you want
Sure.
me to? Okay.
Go for it.
All right. So I'm going to risk never being invited back for a panel like this. I'm going to make 4 predictions about the biggest impact of AI, short term and a longer term. So number one, it's very easy to apply AI in research. We have a lot of advances, AlphaFold for protein folding, but it's a long way from research to drugs and other treatments that have a clinical impact. So my number one prediction, AI is very good on sort of the funnel at the beginning and the basic research, very poor if I have a clinical trial predicting will that trial produce something of importance. And most of the $1 billion in years in healthcare are at that tail end. So my number one, the biggest impact, I think it's going to be a long term, but the biggest impact is getting better AI models for clinical trials. Number two, a basic distinction is between medicine, which treats disease, and wellness, which gives you ways to improve your mental, physical, and spiritual being. So medicine is highly regulated, for better or worse. Wellness is not. So I think some of the biggest impact will be in wellness, where simple things like AI companions and other things can help with all sorts of the problems we have in mental health and other areas. And then I'll do one more, then stop. Well, do two more in 10 seconds each. In science, we're good at AI and cancer, not so good on AI immunology, huge opportunity. And then the biggest near-term impact is hospital operations and medical education. These are not regulated in the same way treatment is, and we could have a huge impact immediately. This is the back office in education by taking what we can do in AI today and transforming how we have, as we heard from the provost, how we do hospital operations, healthcare infrastructure.
Well, you're right. That was horrible.
Thank you.
And you should leave right now versus even coming back. That was great. Thank you. Ben, please tell us about your day job and all the extraordinary things that you're working on and excited about.
Yeah, okay. So I'm Ben Zhao. I'm a professor at computer science. Over the last, whatever, it's been a decade or somewhere about there, I've been working on security and machine learning. And I guess the last few years, particularly since the arrival of generative AI, I've been building tools to protect humans from generative AI, particularly writers, artists, visual artists, and all sorts of creatives, from having their work product scraped, downloaded, trained without consent or compensation. And so, yeah, so much of my work revolves around that. I guess it's fairly popular. In totality, my two tools up to this point in the last couple of years have been downloaded about 9 million times from around the globe, about 160 countries-ish. Turns out artists everywhere around the globe are getting attacked by AI, by mimicry, by impersonation, by legal consumption of their work product and having their careers ruined. Yeah, so I guess that's sort of most of the things I work on these days. Primarily, it's about creating AI tools that disrupt AI when it's used without consent. And, you know, I guess yeah, that's sort of most of what I do. I'm probably the most skeptical person about AI, particularly transformers, that you will find. I certainly am when I'm listed on various different award top whatever people things. You know, it turns out that I'm not that rare when you actually speak to academics in closed settings. Many of us, I think, who work in this field do not necessarily speak quite aloud some of the skepticism we have. So I guess what I will point to is, you know, we can go into some of the stuff later, but the biggest high-profile person who is most aligned with my views on current generation of AI tools would probably be Yann LeCun at Meta. And he's the chief scientist at Meta, which is ironic because he's very vocal about why these generation of architectures are going nowhere, that they're not intelligent, that they never will be, and that much of the marketing about how they could be used to revolutionize everything from code generation and software development to, you know, free reign actions, agents on the internet are very much overblown. So I'll stop there.
All right. So hopefully that's either comforting news or you're a little deflated listening to that, but he's got a lot of good points that we're going to dig into. If Jens looks and sounds familiar to you, it's because he's on a book tour right now, and he's got a wonderful new book that's coming out Monday?
Last Monday, yeah.
Last Monday it came out, and he was on BEZ this week. But let's hear about your day job and a little bit of how you're using AI in the work that you're doing.
Great, thanks, Paul. So I'm Jens Ludwig. I'm trained as an economist. I'm on the public policy faculty, and I run a research center here called the University of Chicago Crime Lab that we started about 18 years ago after a doctoral student in chemistry was shot and killed 2 weeks after he defended his dissertation. So we set ourselves up to be sort of the R&D partner for the public sector to try and make more progress on these big social problems. And as we started to do that, we'd go talk to people in City Hall in Chicago, talk to people in City Hall in New York City, the court system in New Jersey, and the sorts of problems that the government partners were really grappling with were not the sort of cause and effect problems that policy people usually spend their time thinking about, but rather prediction policy problems of the sort that AI has the potential to solve that humans currently are doing. And so I kind of got dragged kicking and screaming into this area, and I have that sort of outsider perspective on this. And so I'll just offer a couple thoughts about this. So one of the most surprising things about this whole area to me, for starters, was how the world is divided up into your response to the question, are you pro or con AI? Which the more I learned about this area, the more weird I thought the question, weird and unhelpful I thought the question was. Because I think in asking the question, people implicitly have a mental model. I think they're making a category error. I think people are implicitly comparing AI to something like the Pfizer COVID vaccine, like a very clearly defined homogeneous intervention or thing. If you see 50 people drop dead from the COVID Pfizer vaccine, you would understandably say this thing's very problematic. But I think algorithms, the right category that's an analogy to algorithms is not to the Pfizer COVID vaccine, but to drugs, right? And imagine how weird the question is, are you pro or con drug? You would say, I don't even know how to answer that question. It's like, what drug are we talking about? For whom and for what purpose, right? And so if you see horse tranquilizer being used to solve COVID, you'd be like, that doesn't sound like a good idea.
Or supplies the government.
It doesn't sound like a good idea, but that doesn't shift my view about drugs as a category, right? And so what I've been trying to think about how we make progress in the policy space in a world in which AI is as heterogeneous as it is. And given that it's so heterogeneous, we can't solve the problem of there being some useful algorithmic applications, some unuseful algorithmic applications by regulating the production process. It's just too heterogeneous of a space. Just sticking with the drug analogy a little bit further, I've come to believe that the big problem is that we don't have the right feedback and filtering mechanisms for AI. We don't have anything like an FDA for algorithms, right? And if you think back to like the 1890s, when you would go to the local pharmacy and there would be a bottle of aspirin next to a bottle of snake oil, we are very much in that sort of world, I think, in the algorithmic space. And so I've been spending a lot of time thinking about how we get more good uses of AI, fewer bad uses, and trying to see if we can generate some examples of illustrative examples that highlight the upside here. I think the risks are very easy to see.
Yep.
I think the upsides, especially in the policy space, we don't have lots of really good examples yet. And so one of the things that we did, for instance, is we, as part of New York City's attempt to close the Rikers Island jail without causing the crime rate to go up, we built an algorithmic decision aid that is currently being used by every pretrial judge in the city that we think the preliminary data are suggesting lets them, by better prioritizing the truly high-risk people for pretrial detention, lets New York City reduce the detention rate without an increase in crime. And our preliminary look at the data suggests it also has the potential to reduce disparities in detention rates. And so that's the sort of thing that we're trying to put out into the world to show, yes, there are obviously risks. There are also upsides. So let's solve the evaluation problem rather than get rid of the whole category of thing altogether.
Okay, super. And the name of your book that's just out?
Unforgiving Places, The Unexpected Origins of American Gun Violence, available at a bookstore near you.
Okay, good. You got it up front. Thank you. All right, Christiane, please.
Yeah, all right. I'm glad you ended with evaluations because I think I'll jump off there. So hi, I'm Christiane. I work at Google DeepMind, and I lead a small team called SAMBA, which stands for the Socio-Technical Analysis of Model Behavior. So a lot of what my team does is build smaller models to help evaluate, so evaluations, the larger models before they go out. I also spent about 4 or 5 of the last several months as the engineering manager for the team that does our assurance evaluations. So right before a new model comes out of DeepMind, there's a sort of, it's almost like an internal auditing system where we audit the model for safety and various other things. So I was the engineering manager for that, and then also the team that builds the infrastructure for doing this. I'm, as of now, going back to just the research side, so doing the model behavior stuff, which is essentially looking at characterizing the sort of different types of ways that the models behave. So instead of looking at red lines or violation rates or building models to detect, was this a violation, was this not a violation, it's more about understanding the different properties of the model. So this might be things like measuring, does it use more anthropomorphic behavior, in what or more anthropomorphic language, in which context does it use that sort of language, in which context would that be problematic versus not. Let's see, what else? Looking at how it can, contextualize historical images appropriately or inappropriately. Does it treat things with a level of care that would be needed for the sensitivity of a subject or not? And so my teams, I think, is one of the coolest teams around. We have philosophers, psychologists, ML people, me, I'm a statistician, engineers, obviously. And yeah, that's more or less what we focus on.
Okay, a lot of ground to cover here. Christiane, I want to pick up on a question, and then Ben, I'm going to ask you to kind of follow up behind it, given your intro. Where are we in the state of AI development? And every time you turn around, there's a new model that has gone up by leaps and bounds. How should we be thinking about where we are in the stages of development?
Yeah, I mean, from my perspective, and I'm thinking about this, pretty much all day, every day. It does seem like we're in a stage where things are moving really fast. It does seem like every other day there is some new sort of thing that comes out, whether it's the deep research type of models, the new more agentic type of models, the ones where the more multimodal models. So for a long time, we've been talking about LLMs, which is really text to text. We're now looking at models that do pretty much any type of modality to any type of modality. We're also looking at some, and I know Ben might have some ideas about this, but like the tool use sort of models. So, looking at models where you can sort of give natural language instructions and then have it, interact with your browser in a way that can do something like maybe, say, hey, put on this map all the best pizza places in town, and it'll actually go and do that. That feels like things are really happening. The other area that seems like it's moving fairly quickly is the sort of interface between robotics and sort of natural language. So being able to give robotics natural language instructions, like put the rubber band into the cup and then tie a bow or something like that. I think robotics is a pretty hard nut to crack, but I've seen some pretty compelling demos too. And so
Okay.
that I think that's the state of where we are. Things are moving fast. There's a lot happening.
Okay. Ben, you started off talking, and I don't think you used the word cynical, but
Sure.
But where do you think we are in the development of AI? And also, I know you have some real thoughts on what the limitations of it are.
Yeah, you don't want me rambling for too long, so we'll take a smaller piece. I mean, I think definitely there's a lot of things going on. There's a lot of growth, but when you look a little bit deeper, I think in terms of the fundamental architectures and where we are with respect to improving them, I think we're near a standstill. Whether it's the size of training data, whether it's the capacity of these models, whether it's the ability of models to extract data from the training data, I think all those things were hitting a limit. You can see licensing deals with companies for human content. That's a fairly regular occurrence now, aside from the legal issues. But those types of licensing contracts are producing what amounts to literal drop in the ocean compared to what data has already been fed into these models. So does it make a huge difference? It will make some difference, but not very much. What concerns me in a way, as an academic in the space, is that I think so much of the VC attention, so much of the industry attention, so much, in fact, of the academic attention has been focused and locked in on this generation of models, that it is, in fact, I believe, stifled our ability to move forward. There are fundamental limitations to transformers. They are asymmetric. They do not have composability. They do not have memory as we know it. When you ask it any question, who is Liam Neeson's mother or sister, it will give a perfectly good answer. And then if you turn around and say, who is this person, given that name, it will have absolutely no idea. And simply because it sees many more copies of training data that mention Liam's name first. And that is what is able to pattern match on. So, there are fundamental limitations that I don't believe we're going to get past in this generation of architectures. And what concerns me is that whether it's VC money or industry money or engineering or academic research money, we're not exploring what is beyond transformers. And so I think we're kind of stuck here until the money runs out from the VCs, and then we are forced to reconcile the limitations of this generation of models, and then we can move on. Now, there's a caveat that I want to throw out, and I think I should have spoken this earlier. A lot of what my colleagues here are saying, talking about the good sides of AI, are absolutely legitimate. They just don't happen to be reliant on generative AI. There's been AI that's been around for decades, and especially in the last 10, 12 years, classifiers, discriminatory, deep neural networks that identify objects, that identify patterns, that extract data from network traffic, from population traffic, from sociology data, census data. All these things are absolutely legitimate, and those models are fantastic. And I spent probably close to a decade of my career building defenses for those kind of systems. It's the newfangled generation of generative AI that produces text, that produces audio, that produces images that mimic human output that I find problematic, both in terms of their procurement, but also I think in terms of their limitations and what they can do. But a lot of the other applications are absolutely legitimate, and they are fantastic and really positive. So I want to put that up.
Okay. Let's get into some practical applications if we can, Bob, because everybody in here is, in one way or another, we're all thinking about some of the way it comes. And I think your area is where AI is changing biology and medicine and healthcare, and that's something that is or is going to touch everybody's lives in this room. How do you think about that?
Well, one of the nice aspects of being at the University of Chicago is interesting people stop by. So about 15 years ago, a fellow named Leroy Hood stopped by our center and threw out a question which only took me about 10 years to digest. So let me tell you the question, and then I'll answer your question.
Please.
So we had, as I mentioned, precision oncology is about using your genomics, your epigenomics, your metabolomics to design a personalized treatment for you. We had hoped that we would have made progress. We've made some progress. We'll make more progress. My role is to make sure that that's data-driven, that we have a large collection of data. And we had built a large system. It's used by this month it was used by 130,000 oncologists around the world. It's one of the largest used systems. But Leroy Hood asked the simple question, what if we flip this around? What if you take that same approach and try to improve wellness? So he coined the term with his colleagues, predictive, preventative, and personalized. So 3 Ps. Whenever you have something that seems to work like that, they over time add more Ps. But for this short discussion, we'll stick to 3. Predictive. And so this was before AI. So if you think about the data, and so my goal is to get data and to build these, just as we heard, these small to mid-scale models that work in conjunction with larger models. You can do things to improve wellness. That's the predictive aspects. The preventive is to use the power, and sometimes we talk about digital twins. Can we create something that's a reflection in real time of the data about you that interoperates with other systems like simulation systems to do what ifs, to decide.
Practical example of that. Medicines on the body.
For this preventive, how can we take the smallest possible changes, like 2 minutes, a 2-minute activity, high intensity activity? What will that do if you do that every day?
Okay.
How can we take a simple activity you're doing, like after breakfast, you take a walk? And then how can we play that in the future to improve your wellness? And what would it look like in 10 years? So, and then the personalized, how do we do that with the data about you? So that's a lot of what we do, is we not only build these predictive, preventative, personalized models for disease, we're starting to do this for wellness.
Okay. Jens, I want to get into some of the practical application on some of the things that you're doing. And I wonder if you can talk in the work that you're doing, how is AI being applied to really address some really complex social problems?
Yeah, let me let me talk a little bit about the biggest challenge facing the city of Chicago that we've been working on, which is the gun violence problem. And I think one of the fun aspects of working on gun violence as a public policy guy is every city in the country, Chicago included, has absolutely no money to spend on this problem that is the number one concern of the public. So it's an insanely constrained optimization problem to try and solve, which then forces creativity. So I think one of the things that one of the steep parts of the curve that I think cities are not doing nearly enough on is capitalizing on the fact that there is a ton of predictable structure by time and place to gun violence. So let me just give you a little concrete example of what that looks like. We could probably even see it from, I guess, through that window, you could probably see it. There's a liquor store at 57th and State Street that is open until midnight every night. Almost every other liquor store on the south side of Chicago closes at like 9 or 10 p.m. Why does that one stay open until midnight? My guess is that there's an alderperson with a very nice speedboat that's related, whatever the cause, that's open at least 2 hours later than every other liquor store. So every night, everybody's going to their local liquor store up until 9 or 10. And then at 10 o'clock, all of a sudden, people from all over the south side of Chicago who want more booze, I've got a beef with you because your sister did this thing to my girlfriend, and I've got a beef with you because you did a thing with him. And all of a sudden, we're in the lobby of Ike's Liquors between 10 and midnight every night. And I have spent a ton of time in the detective bureau at the Chicago Police Department looking at security camera footage of people being shot point blank in the head, in the neck, in the torso, consistently between 10 and midnight, night after night after night. And if you talk to commanders in the Chicago Police Department and police departments all over across the country, and you ask them their patrol strategy, they will ultimately tell you their strategy is some version of patrolling randomly, which just seems absolutely insane in a world in which between 10 and midnight every night at 57th and State, there is a huge gun violence hotspot. That is basically what using AI and data is to target police resources, right? Your common sense would tell you it is madness not to park either a cop car or a nonprofit violence interrupter or a security guard or something at Ike's Liquor Store between 10 and midnight. So we've been building AI tools that help police departments do that and helping train the leadership of the police departments to implement, to basically learn about the importance of following the data and follow it. And there was a randomized control trial. This is one of the few policy randomized control trials. LAPD many years ago did a horse race between data-driven targeting of where should the cops spend your time according to a statistical model versus where should the cops spend their time according to a human intelligence analyst. And the data targeting basically doubles the crime prevention that you get from a given level of police spending. So if you think, what would a city like Chicago wish that it could do in a world in which we have this huge problem and no additional money? Building data tools is like a rounding error as a fraction of the city budget. This is a super scalable, super cheap way to get way more social good per dollar spent. That's the sort of thing that
Okay, fantastic. Christiane, I wonder if we can keep going on this concept of criminal justice and AI, and where does societal bias come into this question of doing some of the things that Jens is talking about or that we have to think about when AI models are being trained?
Yeah, that's a great question. And Jens and I have worked in the past on some of these issues, so it's nice to be sitting here next to him again. Yeah, so I think the issue comes when you think about how the models are trained, right? And so if you have data that reflects some sort of historical bias, so in the case of the policing data, depending on which sort of policing data you're using, maybe if police are patrolling one area more than another area, for example, there may be relative to the level of crime, there could be more reports in the data set that could be used, right? And so that, if you were to then build a model based off of that, as opposed to say something like calls for service, you would reinforce that same bias. So if they'd been patrolling this area, maybe it wasn't because of, some true increase, like Ike's liquor store, but some other reason, or they have some bias towards that location, you would sort of reinforce that sort of thing. These are things that I'm not working on, like in the policing or the sort of criminal justice context so much anymore. I think in the context of the big AI models that we're talking about now, the way that this arises is when you look at some of these tendencies that I was talking about that we want to measure in the models. So a popular type of bias that people look at is how models respond when presented with something about occupation. And so people might be concerned that if you ask a model a question about a CEO, that it's maybe always returning, images of men or text about men. And this sort of arises from the same problem where the underlying training data may have more or fewer examples of different types of people. And so, how do we handle that then? I think that's the next question. There is some issue around, getting more representative data, thinking through, how do we get the more representative data, evaluating whether it's in there. But there's also this, need to do robust evaluations to figure out in what context would we actually care if this is happening? What are the real contexts of use in which if this did come up, it would be a problem, and how can we design evaluations to see if that is actually happening? In the newer generation of models where the data that's going in is so unstructured, it could be a picture of something, it could be really anything, sort of the sky's the limit in terms of what you could put in. And also sort of in some ways what can come out, which makes the evaluation question so much harder when it comes to bias. When we're talking about the traditional models, like some of the risk assessment models, right? We kind of know the specific categories that go in, we know the types of data that could go into these sorts of models. And so you can really get a fairly full picture of what the biases might be when you're doing that sort of thing. It's really, you can sort of write down metrics and anticipate, okay, if we see this, if we see, say, a higher false positive rate for Black defendants and white defendants, we might say ahead of time, that would be a problem. When we're talking about these really open-ended inputs and open-ended outputs, it becomes much more difficult to characterize what even is bias, what is a problematic bias, and even crafting the inputs to be realistic so that we can catch cases that would really cause a problem in the real world rather than just cases that are sort of contrived.
So those biases is probably affecting everybody. Some of your work, I'm sure, there's bias concerns and so forth, right?
Yes and no.
Okay.
So I take a slightly different approach to this. So there's obviously bias everywhere. There's bias in data, et cetera. When we look at a problem, my goal is not to produce a general purpose AI model that's used by millions of people, has a lot of edge cases, and has to be protected. My goal is to do something to improve a particular task in medicine, biology, healthcare with some broad impact. I take an approach called TASM, T-A-S-M. So it's sort of the reverse process. I ask, what's the task we're trying to do? Is a task for an emergency room might be just to have the doctor to have more time. So you might automate the amount of time he or she takes to do discharge notes or to do patient updates. So the task might be to do that. The task might be to make a diagnosis a little faster. So you start with the task, then you look at the automation model. Is this going to be done completely automatic with human-machine teaming, with human supervision? Then you look at what's the system that delivers it. And in most places, the model is a small part of the system. The system might be something in the emergency room and back office at the clinic. And then finally, after you understand what the task is, what the automation model is, what the system that will deliver it is, then I build the model.
Got it.
So by the time I put all that constraint on, I have a whole system that delivers the impact, and I have guardrails and everything I need to deliver the output. That's because I can choose the problem to win. I don't have to build this model used by millions of people.
Okay. One of the things, if I can, Ben, come back to you, is that especially when AI was getting going, there was a lot of concern, for lack of a better word, about the creative class and whose work was being used to train these models. And you ended up coming up with a program that really got global attention called Nightshade that is still quite prominent. I wonder if you can summarize this problem and then what Nightshade actually does to help address it.
Yeah, I mean, I guess it's a really substantial problem to sum up, but I'll try to do it quickly. I mean, the issue with many of these larger scale models today, particularly generative models, right? So before this, and in very specific domains in medicine and other cases, you have bespoke models built on curated data from the professionals, right? So in medicine, you know where that data is coming from. You are licensed. You get the right doctors getting you that good data. All these things. That's what you want in a traditional model pipeline. And then, as of 2021, 2022, it happened that, a lot of folks were developing larger scale models that really needed more data than they could get from traditional places. So the movement was to go online and basically download everything that you can get, terabytes, petabytes. Literally, most models today are trained multiple times on what's called the Common Crawl. Common Crawl is a shorthand reference to everything on the internet, a full snapshot of the entire internet, and multiple copies of it, multiple snapshots of it. And then that's just one part of the data set that they're training on. So in terms of visual artists, the most famous one is called Leon 5B, which is 5 billion images, literally 5 billion pointers to 5 billion images anywhere on the internet that were collated by a group in Germany. And so the issue, of course, is that when you're an artist, particularly independent artists, or most artists, visual artists actually work by contract or freelance. That is sort of the norm in the profession. The way that they sort of continue their profession is they post samples of their art online. But the trouble with this is that when you post your art online, you are by default exposing yourself, especially in this age of AI, to being trained on without your knowledge or consent, but more so to being mimicked. There are now models that you can take samples, 15 to 20 samples of any particular artist's work, and you can literally fine-tune a model very quickly in maybe an hour, maybe less, on a laptop to basically produce a full mimicry of that particular artist's style, their textures, their palettes, their sort of compositional preferences, and so on, and now be able to literally wear that artist as a skin. And now you can say, give me a kid wandering around the forest in the style of, Carlo Ortiz or anyone you prefer. But in doing so, you've effectively speaking destroyed the life of that artist who's now just been sucked into a model. Because no matter what, their value as an artist will never be the same. But now we actually see that you go online, Google, and you'll oftentimes see that when you search people, particularly artist names, the results that you get back are not their own artwork. They are, in fact, mimics of their artwork produced by AI models. So Nightshade is a tool. It's actually the second tool. The first one is Calculates. Nightshade is meant to try to restore some of this agency. It basically alters images, particularly visual images, in such a way that it teaches AI models something different from what we humans see. So you can run a photograph of a dog through Nightshade, and for example, it will alter it in very, very sort of subtle ways, in such a way that when an AI model tries to train on it, it will see and learn all the features of a 1950s Chevy. And so because models rely on data, this acts as a nice little deterrent. Artists can basically apply this to their own artwork and photographs and so on. And if companies, whoever, despite their best urgings and do not scrape and robots act, all the other options are at their disposal, when those have all been exhausted and the companies still take their images and train on it, the images will actually harm the models rather than help them. So it's a way of trying to restore the balance of power in a way, because regulatory forces and legal cases are years in the coming and are not going to be enforceable in a technical way in the short term.
Okay, excellent. It's really some remarkable work, and there's a lot you can find online about Nightshade and the impact on it. We've got just about 5 minutes left, and I think everybody in the room is interested in exploring the next stage of their lives, their careers. And I wonder, Christiane, if I can start with you, and if you're saying, here's some things that I would like to have everybody in this room think about when it comes to AI and how they should be thinking about bringing it into their lives and learning about it. What pieces of advice would you like to wrap us up with?
What do you think? It's maybe both easy and hard to go first because there's a lot of pressure because nothing's been taken. Let me say this. One of the things that's been surprising to me in working with AI a lot is how much we really need people who have a lot of clarity of thought about what they're trying to do and an ability to express that in ways that are really specific and clear. And I think if you have those skills, you can actually use AI to do a lot of things. So the less clear that your description is of what you're asking it to do, the harder it is going to be to get it to be able to work for you. And in a lot of cases, what I found in my work, the hard part is actually clarifying and expressing and sort of like taxonomizing exactly what the thing is that you're trying to do, distill it down, and then sort of communicating that clearly, and then things seem to fall out from there. And so that's what I would say is I think, sort of exercising that muscle and getting used to how you interact with the models to get them to do the thing you're trying to do, even if you're not coding things, for example, is
Okay.
going to be a really valuable skill.
Great one. Yen, same question, please.
Yeah, here's my outsider's perspective on this. Is when I look at what there's just a ton of energy in AI as I see it right now, that is all about automating what people do, and I think part of that stems from. I'm happy to be corrected if this is a misunderstanding of the direction of the field, but part of that comes, I think, from a lot of the earliest tasks that computer scientists were working on were things like human perception tasks that people do almost perfectly. Here's a picture, is there a cat in this? Right? And so you don't have to think very hard about what the human is doing, whether they're doing, because human benchline is perfect, let's do that. Now, as we're starting to see AI diffuse more and more throughout the world, it's being applied to problems that humans do imperfectly. Decision-making tasks like a judge making a decision about who to jail or not awaiting trial, these are really, these decision problems are insanely complicated and people do them very, very imperfectly. And so merely automating what people do in those sorts of applications is settling for something, it's got two problems. One is it's settling for something that we shouldn't be settling for, imperfect human performance. And the flip side is it's leading to a very grim future for humanity where nobody's got a job and this is like, WALL-E, we're just on the giant spaceship drinking our milkshakes on the lawn chair all day. And, I've been working with my friend Sendhil Mullainathan, who's now at MIT, on thinking about how we build AI that augments what human capacity instead. And the reason that I mention that for this group is if you think about that sort of application, we want to figure out a way to get the algorithm and the person together to be better than either one alone. You can only do that if you not just understand the algorithm, but you also understand what the human is doing in that application. That turns out to be a super important input into designing useful AI. And that's the sort of thing, even if you don't know a lot about AI yourself, you know a lot about what people are doing in these important contexts that they're doing imperfectly. That is, I think, a hugely important input into the design of these sort of human plus machine systems that we hope will augment people and make them better.
Okay, excellent. Thank you. Ben?
I was just thinking, and I love Yen's comment about WALL-E. I would just tweak that a little bit. The WALL-E, I think I went through different stages of what I hope an AI future would be, right? I think when I was growing up, I thought it would be the Jetsons, right? I thought it would be, was it Rose or the robot
Rosie.
flying around? Rosie, thank you, doing everything that I didn't want to do. I think that's gone. I think robotics is, would love for robotics to get there, but right now, I went through a version where I thought WALL-E was going to be the thing, and I thought that's not great because we're all going to be obese and just feeding ourselves with junk food and lying and wasting our time. But it's not the worst. Unfortunately, I think today perhaps we're heading towards a slightly darker version, maybe slightly something more to the tune of Elysium, if people have seen that, or District 9. I think what these tools right now are doing is that they are blowing up the wealth gap. And I think it's destroying the medium and perhaps lower class of employees, and really concentrating wealth in the hands of the few. And I think we're going to see the Elysium version of that, where the large majority of people are living in a much lower standard of living, and then you have a very small subgroup elsewhere. But I guess sort of that's a distraction. What I would say is I think one of the big questions for me is that I think generative AI is so good at producing things that mimic reality, that mimic human work product. But I do think that it falls short. And I think in the future, one of the biggest challenges for many people, I think for all of us, will be how we distinguish real from synthetic. And we're looking at issues with art in this space right now. We're looking at issues of deep fakes and identity theft and voice mimicry when high-profile people's voices are used without their consent, sometimes just for pranks and just for profit, but oftentimes for scams. And FBI just released a report that says something like, scams against the elderly has hit an all-time high. Was it 16 billion? Maybe other folks had the more precise number as of last year. And that's a space where basically Gen AI, unfortunately, will have great impact. So I do think that thinking about how to find the authentic human voice and how to protect that human voice, whether that being literal voice or music or writing or art, I think that's going to be a big challenge for all of us in the future.
Okay, good. Bring us home.
I want to give a slightly broader perspective and tie it to what we heard in the morning very quickly. I started my career working with these programs 30, 40 years ago that could do derivatives and integrals and some series better than any mathematicians, like Maple and Mathematica. And those programs, based on algorithms and data, mathematicians turned out to have a pretty good run. So did computer science the last 30 years. So in this perspective, and tying it to the morning, if you're faced with a problem, it's not always obvious that data is the right solution. We heard from David Brooks in the morning that you have a very rich life. It's not always data driven. On the other hand, if it is data driven, that is, if you want to solve the problem with data, then number one, understand the data. Number two, understand the model. And number three, understand how it's going to be deployed. And then if you apply these kinds of rules, AI is just one of the algorithms, one of the sets of data you can use, but it's your responsibility to choose the right data, choose the right model, choose the right application. That may or may not include AI. If it includes AI, the only way you're going to understand that is what sometimes we call extreme experimentation. You're going to have to do a lot of experimentation to see how it's going to be applied. But in the broader context, this ability of using algorithms, machine and models and data has been going on for 40 years, driven by more data and more computation. It's going to go on for 40 more years, and it's up to the people in this room to have the perspective to know how to drive that.
That's a great summary. Thank you for adding it. We've heard some great speakers. Please join me in thanking them.
Big Brains is a production of the University of Chicago Podcast Network. We're sponsored by the Graham School. Are you a lifelong learner with an insatiable curiosity? Access more than 50 open enrollment courses every quarter. Learn more at graham.uchicago.edu/bigbrains. If you like what you heard on our podcast, please leave us a rating and review. The show is hosted by Paul M. Rand and produced by Leah Cesarine and me, Matt Hodap. Thanks for listening.